This week on Today in Space.
And I even heard rumblings from NASA yet over 6 years ago that they were looking to develop additive manufacturing tech that meets the criteria of reducing supply transportation from Earth to space.
Yeah.
Transportation of supplies and infrastructure from Earth to the moon is astronomical. Like you're looking at a starting price of 5 million US dollars for every 1 U of payload. Now, that's astronomical. That's going to pile up so fast. And by the way, there's absolutely zero guarantee that that supplies is going to make it there safely. If something happens with that rocket launch and you've got human lives up there on the moon that are depending on that payload, you can't afford to mess around with that.
Welcome, everybody, to Today in Space, the All Things Science podcast. I'm your Space Science podcast host from the East Coast, Alex Giorfanos, and we're here for another episode of People of Science, where we learn about the humans behind the science. And I remember when I was looking into STEM and there wasn't a lot of jobs on the market at that time, I was always trying to figure out, well, what job would I like? I always would have loved to have known more people. And so that's what this podcast is, a gift from me to you, is going out there, finding people who are working in the industry and sharing why they were passionate about it and what they're doing today. Today, we have our guest, Madison Feehan, the founder of Space Copy, and we're going to learn a little bit more about her. Madison, thank you for joining us on People of Science.
Hello, Alex. Thank you so much for hosting me. Pleasure to be here. I've been told that my journey in space is both interesting and unconventional. And
Perfect.
I like to think, hey, there's no one size fits all narrative when it comes to science, especially as an entrepreneur. So happy to be here.
Awesome. So let's start with a little bit about you. Tell the folks about who you are, kind of a little bit about your background and what you're doing with Space Copy.
Yeah, absolutely. So I have a background in commerce, actually, business technology management, making the transition to international business later in 2024. Have a background in entrepreneurship and innovation from Harvard Business School.
Mm.
So I had some really great acumen on the business side of things that helped me kind of power through into STEM. Science has always been kind of my passion. Ever since being a kid, I was always interested in space, always interested in 3D printing, and that's kind of where the inspiration for Space Copy came from. So let's get some baseline facts down packed here from the beginning.
Please.
I am the founder of and heading up an incredible international startup called Space Copy Inc. We're based in the United States and Canada, and we are working to create additive manufacturing devices that use what's called a novel selective laser melting process
Mm.
that allows you to convert lunar regolith or moon soil into a feedstock that is capable of printing various different kinds of supplies and infrastructure for those lunar missions. We've been in business since 2022
Mm.
and gained a lot of interest from various stakeholders within the industry, government, private academia. Now that our traction as a startup is starting to solidify, we are embarking on our research and development phase and
Mm.
looking to begin prototyping and bidding on some federal grants in 2024. So we're super excited.
Awesome. So to say it another way, your company is working on using the soil from, say, the moon, Mars, any other body, turning that into something that you can then build structures on the surface for humans and whatever else we need to do.
Exactly, exactly.
Awesome.
And there's also an Earth use case too. So, say for example, you're out in the middle of the desert or the Arctic, you're in a remote, extreme environment, and you don't have
Mm.
access to standard infrastructure. Our 3D printers, of course, you can take them out to those remote areas, create that supplies and infrastructure stuff that you need. If something breaks down on a machine, you can create the repair part in situ using the actual soil or sand or whatever it is that you have nearby. And that's going to completely transform both the space industry, defense industry, and a whole bunch of different kind of manufacturing subsectors that are
Yeah.
relying on these different additive processes. And
Mm.
we're going to completely change that game and disrupt that industry.
When did this, so 2002, the company started. When, tell me more about your path leading up to that, because I'm interested into kind of some of the decisions that made you want to start a company like Space Copy, because it's a fascinating one where we've the fusion of 3D printing in space. Like it's very excited to talk about this topic. Not many people are. So I'd love to know more about the why for space copy for you.
Absolutely. So yeah, started in late 2022, and inspiration first for me personally came from a prototype design that I'd come up with for a
Mm,
Mars colony that was created using 3D printing.
wow.
Uh, Back then, that was back in 2017. I didn't know the first thing about how 3D printing really operates. I understood the
Mm,
concepts, the different processes, but never really how it works.
yeah.
I did kind of like a research project. It was for my school. Got to create this amazing prototype. It took a lot of time, a lot of effort, but throughout the entire iterative design process and actually creating something like that, it was so rewarding. I
Mm,
had the chance to really work with different CAD models and experiment with different kinds of 3D printing and see what was what. And that thought and that feeling never really left me.
mm,
It was around 2019 that I got an offer to work for NASA as a contractor for their subdivision called NSPIRES, which is short for NASA Solicitation and Proposal Integrated Review and Evaluation System.
whew.
Yeah, long name, lots of stuff to unpack there. If I'm putting it into simple words, that's basically the NASA division that's responsible for reviewing all the proposals that
Mm,
are coming from, say, academic institutes. If there's a university working on a research project for space, it's being filtered through Inspires.
mm,
And then reviewers and panelists, such as myself, go in, take a look at the review proposal, find out its intrinsic merit, its relevance to the overarching goals of NASA and projects like Artemis, and
mm.
see if integration strategy for something like Eclipse mission. And if we find that all of those criterion are checked off, then those are the proposals that get funding. And eventually that's what you start hearing about in mainstream media.
Interesting. So this is kind of the, when we wonder where mission comes from, today, this is a lot of where this comes from. At least, is it just academic and then it's built from there, or other private institutions that are offering things that can be bid for in those projects?
Well, absolutely. Private
Mm,
institutes are a huge part of it. I'd say they probably make up around 50% of the applications that we
wow.
review.
Wow.
And it's great to see too, because there's a great integration between government, industry, and academia, which are like the three key stakeholders.
Mm,
And it's also nice to see that some of the small businesses are starting to get some recognition on these platforms, whether they're working with the larger entities or submitting something entirely on their own. It's
mm.
good to see.
So, how does someone apply to something like this? Whether, in any of those three groups, is it the process the same?
Process is relatively similar, but
Mm,
slightly different on the bureaucracy side of each.
okay.
If you're looking to submit a project to NASA to have them take a look at it, I always recommend, especially if you're a student or early career professional, if you have the chance to go to a university and work with them on a project, then do it. It's your easiest way in.
Mm,
But if you're an entrepreneur like me, then you're going to want to found your own space company or work with a space company to bid on a larger proposal. And they have all
mm.
different kinds of criteria and different subsections and divisions that are dedicated to different programs. So there's a really diverse range of things. And that's not limited to planetary science, heliophysics, astrophysics, those three divisions I've worked in. Biomedical engineering is another one. Physical science, biological science, anything in between that relates to space or Earth, you can count on it being there.
That is very cool. You mentioned entrepreneurship, and on this podcast, for especially for this segment, I think we have a good balance of folks that are in a scientific and entrepreneurial field. Um, how how have you seen that be different than, say, some of the people that you work with in the industry? Because it seems like it's, I don't want to say a rare thing, but it's unique at the very least. Is that something that you grew up with that's always been there, or did you find that later?
Entrepreneurship has always been very deeply embedded within
Mm.
my family. We're all entrepreneurs, a lot of us are.
Oh, cool.
And yeah, no, entrepreneurship is definitely one of my core values. But when you take a look at the space industry and how entrepreneurship fits into that framework, I'd say it's pretty diverse. It's its own breed in itself. When you
Mm,
compare it to how other people do business, if you're a government entity, it's an entirely different landscape. And I myself have been on quite the journey since founding Space Copy, really taking a deep dive into what entrepreneurship is as a sector in itself, and then
Mm,
refining it down to that niche of hardware development for space tech, because again, space tech as an industry is pretty large itself, but then you narrow it down to hardware, you narrow it down to additive manufacturing, and all of a sudden it's this completely customized niche
mm.
sector of entrepreneurship that not a lot of people know about, but in my opinion, it's one of the most interesting things to be part of.
Yeah, tell me some of the interesting things that you've learned along the way, or something that kind of just pops out as one of the most interesting things that you've seen so far.
I have to pick one.
You could do more.
We can pick a few. Let's start with The Mum Test, which
Mm,
is a book that was given to me on maybe the first or second day of a program, because we were in a program with Techstars, which is a
mm,
renowned worldwide venture capital firm for early stage startups. So we went through about a 3-month program with them, and we met some really great advisors, people who are in the space industry who are also entrepreneurs.
mm,
One of them, his first advice to me was sit down and read the Mum Test book. And that book basically talks a lot about how you can convey your messages and how you can learn to respond to people and engage with people, if they're partners, if they're people you want to work with, if they're clients, in
mm,
order to convey your message in a way that's both effective and cuts through all of the red tape.
mm,
Because, and I find this a lot in the space industry, there is a lot of red tape when it comes
mm,
to negotiating and making deals. So if you can find a way to capture your value proposition and find a method of communicating to stakeholders in a way that cuts through some of that preamble,
mm,
you're going to have a quicker go to market, a quicker revenue strategy, and overall better business practices. So
mm.
that was one of my favorite things to learn.
Love that. Folks, if you're anything like me, you're always looking to optimize what's going on. For us, we've got so many things going on between the podcast and a full time engineering job and following along on stuff in space all the time, 24/7. A 3D printing lab that we run, and we 3D print services for people. We're doing a lot of stuff. And a lot of the times people will ask me, how do you stay on top of this? How do you have all this energy? How do you stay focused? And I've gone the route of being very disciplined and trying to stick to it. But let's be honest, there are times where you are just depleted of resources, right? You need nutrients in order for your body to work, and your brain is no different. It's not just about what makes your body work, your brain needs it as well. So, how are you going to do that? I know I've been taking Magic Mind, and it has been my one solution to replenishing all those things that my brain needs on a daily basis. And it's in this little productivity shot that has 55 milligrams of caffeine. The reason I take it is because it allows me to optimize the moments that I actually do have time to work on my aspirational, inspirational stuff, right? My podcast, the side business. We're doing this while working full time as an engineer, building it in the background. So I have to be on instead of waiting. I've got an hour tonight. I don't want to spend 30 minutes getting ready to be in the zone and be in the creative process before I start doing stuff, because then I've lost half my time. This is helping me recapture that. And not only is it helping with focus, it's helping with my anxiety too. It's helping reduce that overall anxiety that I have and I manage on a day-to-day basis. So that frees me up. And it's also replacing my coffee intake. I mean, we're talking 6 cups of coffee was pretty much regular. And I've cut that down in half with Magic Mind. So I would highly recommend it, especially if you're trying to make something of what you're doing. If you're jumping into being creative, if you're trying to work a little extra hard, if you're trying to just focus a little bit more in the chaos of today, I get it. Magic Mind is here to help. So you can use our code today in space 20 and go to magicmind.com. Get the limited 56% off your first subscription or 20% off any item in the store. That's today in space 20. You get 1 month for free when you're subscribing for 3 months at magicmind.com/Jan today in space. That's JAN today in space. And use the code today in space 20. And it's an extra 20% off, which means you get to 75% off. And this only lasts until the end of January, so hurry up before it goes away. Today in Space 20 and magicmind.com/Jan Today in Space. They're doing this for January. So go check it out. Get onto the cleaner energy, cleaner focus movement with us with Magic Mind. Again, it's part of our daily routine. We have the 30-day subscription. Go check it out. Magicmind.com, Today in Space 20. Go check it out.
Trying to think, what's another really interesting thing? I like to say that actually starting a business was more knowledgeable than going to business school.
Oh,
Because
yes.
you're on the ground, you're running, you're always moving, because if you're not moving, you're not a startup. You're always looking to learn new things. If you're refining your pitch deck for the 50th time at 3 a.m. the night before a big presentation, so be it. That's the startup world. I think a lot of really great knowledge that I've learned comes from understanding the startup culture and how it behaves, not just in space tech, but just entrepreneurship in general. I think people have this misconception that you have to be on like a constant grind and you have to always be pushing and pushing. And that can really set some toxic boundaries. And you really don't understand when's a good time for you to take a step back, breathe, look at the greater mission of what you're doing and what you can actually continue following along your path instead of just meeting the next deadline. So I'd say one of the things that I learned through entrepreneurship is it's an uphill battle constantly, but you have to be content with the fact that there's always going to be something that has to get done. You're never going to check off everything that's on your list, and you have to be okay with that. And you have to be okay with adding more things onto that list. And actually, if you just keep doing that and you keep trekking forward and you set that healthy boundary for yourself, saying, okay, this is what I can get accomplished in a day. This is what I'll get done tomorrow. And you can maintain that kind of level-headedness, then I'd say any kind of conflict that would come up day to day in a business, you'd be able to mitigate it pretty good if you keep that mindset.
I absolutely love that. I'm so glad that you brought that up. It's for us, it's something that we're definitely working on here. We talk a lot about the human side, so I'm so glad that you brought that up. Right now, I'm in a few phases of this because, this podcast is pretty much just me um filming, recording, ideating, uh editing. And a lot of that was from starting my 3D printing business early on and providing a service for folks. And then that shifted me into the startup 3D printing world because for some reason I was in the middle of the 3D printing hub of the world in Boston, Massachusetts. Who knew? But the reason I got in those places was from learning those lessons from having a business and realizing, you're gonna have to pack up the package. You're gonna have to learn about shipping. You're gonna have to learn about all these little things, not because necessarily they're interesting, but because they're gonna help you accomplish the task. And so it's kind of an interesting big picture view of something, and then being the operator you just have a better respect, I think, for everything that has to happen. Um, so where are some healthy boundaries that you've um, set in your kind of tenure or your experience now as an entrepreneur? I'd be interested to hear, and I'll share one to give you a few seconds to think. Um, I am answering the why a lot more often than reaching for some arbitrary goal. And I think for me, the why is the thing that ultimately like gives me that drive to keep that engine moving, and it's a much healthier fuel, other than say, oh, I didn't get that job, I'll show them. That's not a very healthy fuel. But something I'm still working on, but it was a big lesson for sure.
Yeah, absolutely. I can see a lot of parallels to that as well for me. I'll take kind of some advice that I got from one of our advisors and also from
Mm,
a program that we were in with MIT a little bit earlier last year. Something that kept being repeated to us as we were going through the program was when you approach people, you have to stop approaching them with an open hand asking for something.
mm,
Most people, if you're in the startup world, you're looking to raise capital, you're looking to gain partnerships, you want something from somebody. And that prerogative is never going to change. That's why we're here. But it's a matter of how you approach it
mm,
and how you address other people's challenges and concerns. Because that's how you build client relationships too, is understanding your customers' concerns. So one of the boundaries that I learned was to stop asking people, how can you help me?
mm,
And start asking, How can I help you? And I found that by asking for advice instead of asking for capital, in exchange, you get more value and knowledge as
Mm,
a result of the conversations that you have when you approach a person asking for their opinion, asking what kind of concerns they're having in their industry, and then going back and reflecting on how you can solve it as an individual and as an entrepreneur.
mm,
Being able to probably loop that feedback mechanism into how I approach business and
mm,
how I approach conversations with different stakeholders, I think that has been one of the better things that I learned in 2023.
absolutely. And to tack on to that, I think so much of entrepreneurship and something that's maybe different than the academic endeavor of science. Um, it's about building relationships, and you know, I think the best result out of entrepreneurship is yes, business and yes, profit comes from it, but it's having a really good partnership between a business giving another business a service or partners working together, departments working together inside of a company. Um, that to me is where it gets really good.
It does, it does.
Yeah,
And I'll border onto another story for a moment while we're on the subject.
sure.
This Space Copy, founding Space Copy, has given me such great insight into space tech entrepreneurship.
Mm,
And more recently, in 2023, I had the opportunity to co-found another startup endeavor. It's called Moon Trades.
mm,
And it's a new trailblazer project that I'm proudly contributing to. So, embarked on this startup alongside a handful of incredible co-founders,
mm,
and we all have pretty varied experience in whether it's technical, business, legal backgrounds, all with this goal of developing two technologies. First of all, we wanted to focus on STEM education, and for that in particular, we're looking to leverage AI and filter it back into an education platform that teaches youth, students, whether it's secondary, post-secondary, or even career professionals, about space and earth science, with a special emphasis on lunar mining and tunneling. And I will segue into that in a moment. But
mm,
to talk about STEM education for a second,
please.
creating interactive learning experiences for students in particular, and for people who are just getting out there into the field, it's a great opportunity to boost your soft skills.
Mm,
And I like to recommend this because this is something that I did as an early career professional, was to go around to different entities and just take short bursts of education, enroll in a program, if it's a few weeks or a few months, get a certificate in a certain discipline, because it gives you a well-rounded knowledge in many different fields and really helps you discover what you're passionate about.
yes.
And at Moon Trades, we're passionate about educating other people and sharing that thought put and really unleashing that creative side to people and doing that through AI and having the opportunity to collaborate with some really interesting people has been really rewarding for us. So we're looking forward to launching the platform later this year.
That's
And
amazing.
I'll thank you. I'll segue back now into lunar mining and tunneling, which I hinted at. The
Mm,
second part of Moon Trades' technology is we're going to reinvest the capital that we get from the STEM education platform, and we're going to develop an autonomous mining and tunneling robotic system that can be used both on Earth and in space. So,
mm,
resource excavation, mining and tunneling operations to create sustainable habitats and identify those habitable zones on the moon. And what's cool about that is we're going to take the same AI platform that
mm,
we're integrating with the education, and we're going to integrate it onto the rover systems that we're developing.
interesting.
So I'd like to suffice it to say, really interesting stuff that
Yeah.
I've learned on the entrepreneurship front. I think I'm taking a lot of knowledge from Space Copy, putting it forward into Moon Trades, and really seeing how these two things develop.
This is all super exciting stuff. Like I don't even know where to start. I think the problem of infrastructure for this boom in space that we're having, we're so blessed to have it. We didn't have it for a decade.
Yeah.
And to see so many people like yourself and hearing that you're working with so many other people take advantage of this time brings me a lot of joy. Um, where do you see so space copy right now? Um, with infrastructure, how do you think that space copy? I mean, it sounds like having just machinery to deal with the idea of regolith, because if you're going to print with regolith, you're going to need to process regolith.
Yeah.
So having all these machines that are seemingly working together and building on top of each other, and it sounds like this AI is also going to become more and more trained. All the data is kind of training it to get better and better over time. Um, where are you guys today? Because this is all very exciting.
Oh yeah, absolutely. When people say, "Where are you today?" That answer changes week by week. We're in R&D right now, so we're just in the early stages. We're working with a lot of academic partners, leveraging their laboratory equipment. So we're using selective laser melting as the 3D printing process that we're looking at.
Hmm,
So we're taking their selective laser melting printers. We're shipping in regolith simulants from various different vendors that have probably around a 99% accuracy to what you'd find on the lunar surface.
hmm,
Various different compositions, mares, highlands, all the different kind of chemical variations that you would find in regolith. And we're taking that, we're processing it, because you're right, you do have to do the processing. So we do a pre-processing method where we're crushing, mixing, and sieving up the particles to try and make them a bit more uniform and easier to handle in 3D printing.
hmm,
Then we're running it through the additive system. Right now, we're keeping our geometries pretty simple, but we hope to dive into a bit more complexity in our future testing. And then after that, we will plan to conduct mechanical testing on the parts to see how well they fare, compressive strength, tensile, all that stuff.
hmm.
And we are excited to be embarking on a lunar analog test later in 2024 to test how durable the parts hold up when exposed to a lunar environment.
Are you guys putting it into like a vacuum chamber and putting it under vacuum and experiencing like an environment or
Very, very similar.
oh
It's
cool.
vacuum with micrometeorite impact.
Oh, that's awesome.
It is, it is. It's very interesting stuff. It's actually not something that's really been done before, so we're very privileged to be kind of like the first industry company
Hmm,
that's coming in and providing these 3D printed parts to be tested in a micrometeorite chamber. So that's something that's not really been done. So we're proud of that.
that's great. That's wild. So that's very cool. I guess I'm not sure how much you can share about the technology behind it, but I'm always interested. I know I've seen, DMLS technology where you've got a bed and then metal powder, and then you're kind of printing onto this sheet metal at the bottom, and then you take it off, machine it off. There's others where you're loading in powder layer by layer and kind of, melting locally wherever it is. Could you tell me a little bit more about how that's working today and where you guys want it to get to for, say, we're on the moon and this is how we're going to print?
Absolutely, absolutely. I'll keep things pretty high level, obviously,
Hmm,
but we basically break down our technology for space copy into four steps.
hmm,
First, we do a spectral analysis of the chemical composition of the regolith. So basically, we take a spectroscopy device, we scan it with lasers, we determine what the material we're working with is consisting of, and that allows us to move into step two, which is pre-processing, as I kind of explained the crushing, mixing part, working with the particles of regolith, reducing them down, filtering out any kind of materials that we can actually eliminate that might be harmful to the printing process. Because, and I don't know if you're familiar, sometimes when you're melting down things like regolith, you're actually producing oxides as a result of that reaction. And what you can do is you can take those oxides, you can capture it, you can put it through a hydrogen reduction process, and you can actually create oxygen as a byproduct from 3D printing.
I'm so glad that you're looking at that now. That's so cool.
So we're trying to capture all these different iterative processes because it's not just a 3D printer, it's a lunar manufacturing device, a
Yeah.
testing and research lab, all in one. So that's phase two.
Hmm.
Phase three, of course, is then moving into that sintering melting process. So as I mentioned, SLM is our primary focus. We've looked at doing extrusion before, and that's honestly not out of the woods yet, but I think that would be more suited for Earth-based applications.
Hmm.
And then final process is the entire software system, because it's pretty well integrated with the different modular parts there. We're integrating AI operating software that uses an algorithm to take data from the spectroscopy, the pre-processing, and the 3D printing to create a combined report of what worked and what didn't work throughout all the different design phases. So that will help you improve for future missions and future operations. And also, It will give you the ability to hopefully understand a bit more about the printing parameters so that you can create more complex geometries as time goes on.
That is very cool. That is very cool. I mean, for me, for someone that's been looking into this strange niche, which is awesome, uh, it what you guys are addressing is so much of the what hasn't been explained. Everyone's so excited about 3D printing Martian dust and regolith and using caves, but I guess in a different way of saying it, you guys are looking at a plot of land, analyzing the material that's there. You're able to process it and then print it and analyze you know, as things are going on. So you'll take something on Earth. You guys can train here on Earth like we would with other missions. Bring it to the moon, and the AI will take what it knows and learn more while it's there. So every time you guys do this, it's going to grow smarter and smarter every single time.
Exactly. That's basically the core principle. And it comes back a lot to the mission behind why I chose to found this company. I have to tell you, at the end of the day, it really just comes down to having an innate passion for the
Mm,
industry, not just for space, but for 3D printing itself. I've personally been really interested in 3D printing for several years. And I even heard rumblings from NASA yet over 6 years ago that they were looking to develop additive manufacturing tech that meets the criteria of reducing supply transportation from Earth to space, because that's
mm,
that's the main use case here.
yeah.
Transportation of supplies and infrastructure from Earth to the moon is astronomical. Like you're looking at a starting price of 5 million US dollars for every 1 U of payload. Now, that's astronomical. That's gonna pile up so fast, and by the way, there's absolutely zero guarantee that that supplies is gonna make it there safely. If something happens with that rocket launch and you've got human lives up there on the moon that are depending on that payload, you can't afford to mess
Hmm.
around with that.
Hmm.
So, transforming human exploration methods is our mission statement.
Hmm.
And I think it deeply resonates with myself and even so many founders in space tech that at the end of the day, we are here to be inspired and push the boundaries of science far beyond what we were previously capable of. And that's a lot of what's behind NASA and the other space agencies, Canadian Space Agency, European Space Agency. They serve as a beacon of light in solving some of these challenges. And more or less, Space Copy's ability to contribute to the merit of the science community for this specific sector, apart from the business aspect itself, is extremely rewarding to know that you're making a difference on how humanity views additive manufacturing, how we view lunar colonization, and even how we look at creating supplies and infrastructure in remote environments on Earth. I want to draw an example here. Say if you're in a natural disaster, and you're coming to a wreckage zone, you're needing to rebuild a city,
Hmm.
wouldn't it be so much easier if you could build the bricks with a 3D printer on site using soil? So much easier than actually shipping in containers and trucks full of building material. When you
Hmm.
could additively manufacture a good majority of it, why not?
Yeah, and we're seeing, right now just on Earth, we're seeing those concrete 3D printing machines that are building houses right now. Early stages, but uh, 3D printing for me, it was getting into the field of 3D printing was through application engineering. And I realized in my 3D printing service business, I was essentially doing exactly that. So I was doing a role that I wasn't even aware of. But for me, I think now I've been 3D printing, phew, let's see, is at least 6 years as a career in the industry, and then another, so let's say 8 years total of just being hands on with it. For me, it's about the application. It's about helping somebody. They have a part, and that very unique there's not a lot of us out there, but people that can look at a printed part and analyze it just by looking at it and asking some questions, what might have gone wrong? Part defect troubleshooting and just knowing a machine intimately enough, watching enough patterns that you can say, I think this is what happened to it, and then start troubleshooting. I mean, that's my day job at this point, is helping people with just that. And so to think about a future where that kind of skill is going to be helpful in building stuff in orbit or on another planet, uh, is just a future that I really hope exists. So,
Does
Um,
exist. It does exist and
yeah.
it's clear and it's right around the corner. People think it's 10 years out. It's not.
Mm. So let's see. From tell me more about some of your earliest memories of what got you into science and entrepreneurship. Is there an early memory that kind of sticks that solidified it? Obviously, you talked about when you started 3D printing that really you got hooked. Anything else younger? As you were going through school.
Yeah, absolutely. Even from elementary school, I remember
Mm,
doing projects about the solar system and the different chemical compositions of the planets.
mm,
And I remember just being utterly fascinated by how the different planets work, how their orbits work, how it's, such different day and night cycles. And I remember just being so fully engrossed in science in general. And even before I knew what engineering was, I was interested in things like electrolysis and just processes that I didn't even fully understand were interconnected, but I just found them to be so interesting. So I'll backtrack a little bit here. Before I became a space entrepreneur, I did start as a contract reviewer for NASA. And how
mm,
I got onto that path was through an amazing entity called the Science Art Exchange. So that is run by a former head of NASA's Johnson Space Center. And they are non for profit, and their goal is to connect youth of all different ages, from as young as 5 years old all the way up to adults, with the STEM industry and combine it with art. So if you've heard the term STEAM being kind of commonly adopted as opposed to STEM, so science, technology, engineering, art, and mathematics is kind of the new era of how people look to approach the space industry. And that's kind of the core principle of the Science Art Exchange. So they were hosting a competition
mm,
about 3D printing on Mars, which is where my kind of school project for 3D printing really kind of came into action. So I submitted that to them. I got great feedback on it. People were interested. They said, you should pursue something like this.
mm,
I followed up again the next year with the Humans in Space Youth Art Competition and prized honorable mention for that. And just getting a little bit of recognition and having the chance to sit down with some subject matter experts who are coming directly from NASA
mm,
was kind of my first opportunity to engage with the science community on a serious scale. And then from that point, it really, really just snowballed. And when I was offered to go take a contract position with NASA after having submitted kind of all my work to them and them saying, well, that's really interesting stuff, but we're working on other things. So thanks for submitting and have a nice day.
mm,
They eventually came back and said, well, do you want to do some review work for us as a contractor? And I got to learn a lot during my tenure in the various divisions.
mm.
Mentioned planetary science. That's my favorite out of anything that I've worked with,
Yeah.
specifically the development and advancement of lunar instruments.
Mm,
I got to see kind of firsthand how different private companies and research institutes were building things like LiDAR, so light detection and ranging systems,
mm,
to integrate onto a payload for a rover, for example, that's going to be used to do sample analysis and excavation reconnaissance kind of around the lunar habitable zones. And really getting to see that stuff up front and looking at what needs to be done for testing, analysis, or practical applications in situ. That's
mm,
kind of the over-encompassing terms that focus a lot on scientific measurement and tying together some of the challenges of living in space and developing instruments that will solve challenges. I've seen some pretty interesting things like rovers, orbital scanners,
mm.
and even miniature measuring devices, which are,
Wow.
good for Eclipse and Artemis missions. And
Mm,
the job itself is very straightforward, getting to see kind of what's being done, taking a good hard look at the criteria of does it match what NASA's trying to accomplish?
mm,
I just say kind of like all those different things leading up to that NASA position, and then even afterwards, getting to engage with different stakeholders and getting to know people,
mm,
senior people who've been in the industry for 40 years, people I look up to as advisors and mentors. Those people really inspired me to just take it to the next level and really pursue entrepreneurship. And I have to tell you, since pursuing that entrepreneurship path, I have become so well versed in many different subjects of space that even just as a hobbyist, I didn't fully kind of comprehend
Mm.
some of those technical terms, and now I kind of consider myself to be an expert in a couple of different things.
Cool.
So, yeah, getting the chance to split time between 2 aerospace startups and getting to engage with NASA and engage with the science community. And there's a great science community here in Canada as well.
Mm.
They're really focused on robotics too, so it's interesting stuff, which robotics, of course, it ties into so many different verticals and subsectors of space development.
Yeah.
And I got to meet some really great people. And I have to say, I love one other thing about the industry is that it's a tight-knit community.
Yes.
And most people know most people.
Mm.
And everybody is usually super involved in paying things forward. They like collaboration because, everybody would rather get a small piece of the pie than no pie at all.
Yes.
And easier to work together in consortiums and groups as opposed to individually.
Mm.
So I think that it's almost like being part of a tribe, this community of space where there's all these different people coming from so many different backgrounds and geographies, and everybody has this super unique outlook on how they approach space tech. And I feel privileged to be a stakeholder in this great, amazing space race and having the opportunity to collaborate and communicate with some really, really cool people.
Absolutely. And it's something that I'm so blessed for this segment and to be able to talk to folks like yourself and throughout the industry. For me, my early story is trying to find my way into the industry. And then I actually ended up finding, I think, my favorite thing, which is talking to people in the industry and sharing that outside to the world. And it's been a very interesting journey, and as we look at Artemis now slated for Artemis 2 2025 at the moment, and um, Artemis 3 after that. There's a lot of things that need to happen for us to get there, but uh, at this point, there's no reason to rush anything. The moon clearly is not the easiest thing to get to in the first place, even though we've done it before, and we just saw with the Astrobotics lander, the Peregrine lander, the challenges that it's experiencing, and so I guess what are your thoughts as we move forward with challenging the moon and trying to get back there and to your point to become regular? If we're going to go to Mars, if we're going to go to the moon, these supplies need to be shipped on a regular basis. And so it's not just we need to land on the moon. It's we need to build a shipping route, an entire supply chain launching from Earth to wherever it is that we're going. Um, I guess what are your thoughts on where we are in that journey of making that big and go as big as you think? I think your unique perspective of what Space Copy wants to do on the moon is really interesting. What are some things in the industry at a big level that you are interested in, think we need to work on, maybe things people haven't even discussed yet? I'd love to know your thoughts.
Absolutely, yeah. The logistics of the greater value chain of how to get to space and stay there needs a lot of work.
Mm.
Uh, I'd say, of course, we're making such great strides as a global space community, whether it's the private companies. So glad you mentioned Astrobotic. Yeah, I watched their Peregrine 1 mission launch the other day, and
Yeah,
I think it takes great stride for private companies in particular to really build, test, and launch commercial space missions.
yeah,
It serves as this foundation to many other kind of small businesses to demonstrate that you can go into this industry and create something so magnanimous without actually having to be a billionaire.
yeah.
Um, Honestly, as far as further development goes, I would love to see a greater emphasis on dividing funding from large space industries and entities.
Mm,
Like take large space agencies like European Space Agency or NASA. They've got so much capital and so many great resources. I'd love to see a more even distribution amongst the small businesses.
yeah,
That would be something for sure that I'd be thrilled to see. I think there's a lot of different processes for how we approach lunar colonization. I think narrowing it down to a set of criteria would be really helpful.
mm,
Um, Another thing that comes to mind for me is how we look at ITAR and international regulations on how we send stuff to space. Because there's one thing is to build the rocket, and another thing is to actually get it sent out there.
Yeah.
And something that I've learned because I volunteer for the United Nations Committee on Peaceful Use of Outer Space.
Mm.
I'm involved with what's called GEGSLA, the Global Expert Group on Sustainable Lunar Activities. And we're going through and we're reading the Artemis Accords, we're reading the Moon Agreement, and we're seeing
Mm.
all of these different overlaps.
So the Artemis Accords and the Lunar Treaty. Can you give folks who maybe aren't completely familiar with that just a little brief intro to that?
Yeah, absolutely. So I like to think of a couple of key ones. First is the Artemis Accords, then comes the Outer Space Treaty, then comes the Moon Agreement and everything thereafter, Rescue Agreement, all that stuff.
Mm.
Basically, there's probably 4 or 5 documents that are generally adopted by the United Nations as kind of like a global framework for sustainable lunar development activities. And what those outline is how do government industries interact with private industry?
Mm.
What kind of regulations do we set up for how to use space resources? What kind of laws do we have on the moon?
Mm.
First of all, the principal thing being nobody owns the moon. Nobody
Right.
owns the space. It's so important for us to maintain that peaceful use
Mm.
on space, the resources and the technology that's developed, because it's a collaborative mission at heart.
Mm.
And just being able to be a part of that, influencing foreign policy and getting to kind of see stuff happening in lifetime, it's absolutely incredible. And what I love to do is volunteer work, and I do that a lot in the space industry,
Mm.
especially in places like the United Nations, because of course they're at the front running of so many different variations of how people approach space tech.
Mm.
But doing a lot of volunteering and mentorship, and I encourage anybody who's in the STEM industry who wants to expand their reach a little bit to go to, outreach programs and attend industry events, webinars, and look for volunteering opportunities for committees and consortiums. Sometimes NASA puts out those open calls.
Mm.
Another interesting place, Zooniverse.org,
Mm.
is a platform that you can go to, and they offer all of these various different kinds. And this ranges from biology to space sciences to humanities. If you want to volunteer your time classifying documents or identifying, for example, I've done like gamma ray bursts in the
Oh.
universe, and they take like imagery. I was doing James Webb Space Telescope imagery of I believe it was neutron stars. What they
Wow.
do is they take infrared images of the galaxy, and it's up to us individual volunteer reviewers to sit there and classify information and identify any kind of anomalies.
Mm.
And that research work is sent back to NASA. They process it through an AI algorithm, and then they actually extract those results and that data, and they put it into articles and publications that further get published into books. And I was doing that for a little while. Yeah, I was doing that for a bit. I still do it every once in a while.
Mm.
And through doing that enough times, not only did I gain a lot of knowledge, but it actually opened some doors of opportunity for me. Like I mentioned, volunteering with the United Nations, it all came from doing other volunteer work with National Science Foundation. And most recently, I'm super proud to say that I'm a contributing author to a book that's about artificial intelligence for Earth resource management. It was commissioned by the White House. It's being released in the next few weeks. Um, it was a wonderful experience, first of all, to be able to write about something like that and to
Yeah.
gain in AI, which is something that I consider myself to be a bit novel in.
Mm.
But I'd say a lot of credit comes to doing those volunteer work,
Mm.
all these different reviews and committees and panels. If you're out there just actively engaging in the industry, you're going to open yourself up to opportunities. And it, in my experience, has been a wonderful thing.
Wow, that's incredible. I hope that is that released? Is that getting released soon?
Getting released soon.
Very cool. I'm looking forward to reading that.
Thank you. Yeah. I'll be keeping it on social media. So if you guys are following Space Copy or me, Madison Feehan, definitely check it out.
Fantastic. So let me ask a little bit about AI because in 2023 we started the year, at least on this podcast, our hope was the reason this podcast, part of the reason this podcast exists is because we don't want science to become magic. Once it becomes magic, then nobody learns anything, nobody understands what's actually happening. So with AI in 2023, it hit the scene pretty hard, and so we started getting a little bit involved to just try and understand it. used ChatGPT a little bit. I currently, for the podcast, we use a transcription and editing software to get the clips out. And we also use like a transcription software to help me do a lot of the work that would have taken me extreme amounts of time. So, what we found was that in our use case of AI, it was helping us to spend more time on the creative endeavors and thinking about how to make this podcast better than taking some of the time that we just aren't at the place where we could pay someone to do that. But also just to free up, I'm a working engineer by day. So there's not a lot of time, and I'd rather spend the time focusing on the why of the mission instead of the what and the how. How for you, how would you describe to somebody who's brand new to AI what it is and the why of why you should learn about it and use it?
AI has been absolutely a roller coaster for me in particular, getting to understand how it works. I was not prepared when ChatGPT launched. I remember logging onto it for the first time and going, "Yeah, okay, sure, this is interesting." Then I inputted a couple of functions and I hit return. And I went, "Oh wow,
Yeah.
that that's a thing now." Okay, so my first experience with it was first of all understanding what is an algorithm,
Mm,
what is machine learning, what's deep learning, and how does that all integrate back into AI. And I've recently been introduced to a couple of different theories. I'm looking into something called computer vision, which in high level is basically how computers identify items from imagery using algorithms.
interesting.
So that's really helpful in applications like data analysis, which of course ties
Mm,
back so heavily into the space industry.
mm,
If we're looking into the why and how versus like why should you use AI versus how do you use it,
mm,
the why, I say the use case is made for itself. You're saving time, you're reducing errors.
mm,
I say it never substitutes for the human eye, but it can really give you
mm.
some assistance in cutting down on your total runtime on something that you're doing if you're working on a project.
Yeah.
If it's something as drastic as creating code for a computer science program, or if it's something as simple as trying to estimate what kind of mechanical testing you should do on a printed
Mm,
coupon after doing some additive testing, then that's a great application for how you can use AI. And
mm.
for moon trades, I'll flip the focus a little bit because moon
Yeah.
trades AI education platform is going to be leveraging a lot of AI. Um, Obviously, we're looking at things like Synthesia. So that's
Mm,
an online platform that integrates AI to create videos from text. So it will actually create like a digital avatar that will read to you and make like an interactive learning experience.
wow.
That was something that we had looked into. We haven't confirmed that we're using that yet, but
Mm,
I personally thought that a technology like that was super interesting.
definitely.
Also, one other thing that I wanted to mention, and this borders on AI, but it's digital twins
Mm,
is a really interesting concept to me. So basically simulating how something's going to look and how it's going to behave
mm,
using AI. And what's really useful for that for lunar applications especially is when you're going into creating a really high cost and complex hardware system, you can use AI first of all to simulate what the product is going to look like. And then you can put it in an analog environment and test it with virtual reality to kind of estimate how that
mm,
machine is there. What happens if radiation comes and hits the machine? Is that going to decalibrate one of the sensor functions of the cameras? What's going to happen if there's temperature gradient extremes? Instead of actually putting a rover into a deep freeze and operating it at minus 150 C,
yeah.
then you could actually use digital twins to simulate that and figure out, how do you work things like fuselages and wiring and how do you do radiation hardening?
Mm,
Instead of actually learning these things the hard way, AI gives us the opportunity to troubleshoot before the problem actually gets here.
mm,
So being able to leverage AI in that function as a space entrepreneur is definitely something that I'm really, really happy that we have that we didn't have 5 or 10 years ago.
mm.
So props to everybody who's out there creating AI software because us space people really need it.
And it seems like the inevitable for human spaceflight, especially long term. It feels like the Star Trek model is what's going to come, having a computer run a lot of the things, the a lot of the functions of the ship as you're traveling and your colony, whatever it might be, it feels like having that partner is going to be really, really important as we become more regular of living in space and working in space.
Absolutely, absolutely. The way that technology is being integrated into how we function in space is really going to be the core of what shapes the Artemis generation. And we are the
Mm,
living Artemis generation. We get to be the ones who make that decision, and we get to watch it happening in live time.
mm,
Um, if I'm looking at how technology is being integrated onto future payloads, I'm particularly really excited for some of the upcoming launches in 2024 and
mm,
ending 2025, 2026. I'm really excited to see how they look to integrate AI into operating softwares, or how they look
okay.
at taking data that they analyze during in situ missions and bringing that data back to Earth and using AI to process it.
Mm,
Like, take for example, I know one of the big buzzword launches that's going around right now is Viper's search for water on the moon.
yes.
Well, to my understanding, they're going to be using a whole bunch of different LiDAR and spectroscopic instruments to determine where's the best spots
Mm,
for water ice deposition. And that data, of course, it's going to be, analyzed by some of the best scientists in the world, but also to have that opportunity to put it through an algorithm and see how
mm,
that functions and if it's accurate. That's going
mm,
to be, I think, a building block towards lunar colonization, because if we have computer systems that are at least somewhat reliable,
mm.
then you're limiting the amount of human error that goes into building technology and shipping it to the moon.
Yeah. It's a brave new world of how these things integrate. And kind of going back to the infrastructure thing, it feels like the space industry is at a really interesting place at infrastructure because it really hasn't grown much since we went to the moon with the Apollo era. I'm oversimplifying it, obviously, but we saw with Artemis 1, there was, I believe, an overload of the deep space network because those CubeSats were just sending too much data for it to process, if I have that story correct. So it feels like there's this opportunity. We talked with our other uh, friends like Jordan Noon, um, venture capital trying to combine uh, and Jenna Bryant the private with the military side because there hasn't been this integration on the military side for all these private technologies and obviously making sure that it's safe, secure, and effective. Um, are there some things, just thinking about AI, that you think, aside from data analysis and helping cut through the stuff that comes back, is there some place that you could think of that AI would be useful in the next 5 years, especially Artemis, right? It's Artemis 2 and 3. If you had the choice of implementing an AI system for that, for the infrastructure, or something else around the mission, what would you choose?
Oh, that's a tough one. For Artemis, and I say this as a proud Canadian who knows that one of our astronauts is going to be aboard a future crewed mission and hopefully one day operating our 3D printers in space.
Yeah.
I'm looking at AI in regards to infrastructure development on the moon specifically.
Mm,
It trails back a lot to me for how we look to integrate AI into both space copy and moon trades as technology. So I think that algorithms will become almost mainstream for
mm,
how we identify where we're putting astronauts down. I know people were talking peak near Shackleton as being a good region because
mm,
of the good constant daylight and not too many differentiations in permanently shadowed regions and stuff like that.
mm,
When you're out in that terrain, though, you really don't fully understand what's out there.
mm.
Oh, Chandrian 3 did a really good job of kind of giving us a sneak peek into what we're expecting with Artemis,
Yeah.
being able to have, fleets of different systems that are being launched and actually set down on the lunar surface to do that reconnaissance
Mm,
and really analyze the terrain before you start building. Because first of all, you need to be building in a stable zone, right?
mm,
Um, if you're looking at creating infrastructure for roadways or launch pads, for example, you need to do a little bit of recon and make sure that the ground you're working on is solid and stable and it can handle the
yeah.
pressures that are associated with landing a rocket. So I think AI is going to kind of trickle back down into the value chain with logistics and infrastructure development in that function. First of all, being able to help us predict where we're going to build infrastructure in the first place, and then coming back into the iterative processes of additive manufacturing, demonstrating how exactly is additive manufacturing going to be accomplished in space using in situ resources. I think AI can help us determine a lot of how we approach process parameters
Mm,
and how we approach handling volatile materials like regolith. And of course, it's nothing like what you see here on Earth. Even the simulants, as accurate as they are, it doesn't
mm,
take into account things like electrostatic effects,
mm,
different traces of volatiles.
yeah.
And I mean, stuff can be carcinogenic, and you do not want that stuff getting inside equipment or much less
Mm,
human lungs.
mm-hmm.
So looking for AI systems that's going to help us mitigate challenges and help us with the iterative processes of additive manufacturing to make sure that infrastructure development is smooth,
Mm.
clean, and easy to deal with. That's where I see AI going in space.
I love that. And I think as someone who works with metal powders in 3D printing, they are I can't even imagine what they would be like to deal with in zero G. They get everywhere with gravity.
Yeah.
So and we know the early astronauts, they all got sick, even with basically perfectly sealed suits. They still got stuff in, it still got back in the capsule when they were, you know, trying to come back. So to think about how to deal with that along with charge and things that you normally don't deal with, um, I think AI is going to help us chunk through that data. Um, have you guys thought about, because I do see this as someone in the industry for, it seems like uh, the best folks out there have people who are hands-on, working intimately with the people designing and engineering the devices. How much thought and resources have you gone into with Space Copy and thinking about integrating kind of the human behind the machine and having it trained side by side with the AI? Or is that a consideration you guys have taken already?
Oh, absolutely.
Mm,
Our entire operating system, we're taking in the user-centric design aspect, is what we
mm,
like to call it. So right now, and this is a bit of experimentation on our part as well, because we don't know when exactly we're going to be launching to go to space. Like we hope to have the prototype with the selective laser melting that's done in 2028, and then hopefully something with FDM that's done even sooner. But we don't know when exactly that's heading to the moon.
mm,
Now, let's say that we get the 3D printer to the moon before humans get there. Then we have to get that AI and autonomous function really ramped up and up to speed with the production requirements for additive.
right.
But then take a step back and look where we're going to be in aerospace 10 years from now. There are going to be humans on the moon. There are going to be 3D printers on the moon.
Mm,
And that's where you really have to take into simplicity of design. You don't want to go out there and build some really complex instrument that nobody knows how to use. And then what are you going to do? You're going to call up the operator and ask for a user manual when you're on the lunar surface.
yep, 100%.
You'd be calling them up and saying, Houston, we have a problem.
Yeah.
So when I think about user-centric design, and this is something that we're doing right now, because as I mentioned, we're heavily into research and development, and we've got a stellar engineering team with us right now who are working out the technical parameters of the design.
Mm,
And we're thinking about a few main things. Of course, AI borders into this conversation naturally
mm-hmm.
because the algorithms are going to be integrated into the operating software.
Yeah.
But also, how does a user turn it on? How does it clean itself? Is it going to be self-cleaning? Do you have to press buttons? How do you check supply levels? How do you
Mm,
check to make sure that, your laser heat is calibrated and that there's a sufficient energy density and that the temperature gradient is even across the build plate? I mean, we could go on for hours
all
and
of
hours,
all of the things. Yeah.
but at the end of the day, as long as the design is user-centric, it's relatively easy to use. Like you take a standard 3D printer that you have here on Earth and see what you can do to make it not more complicated. We're talking about integrating spectroscopy and pre-processing through beneficiation,
Yeah.
and then having selective laser melting all in one device. And obviously, that's going to involve a lot more systems than a standard 3D printer.
Mm,
So taking a step back, looking at the operating system, seeing what actually has to be done, and then going back and saying, what can we do to make this simpler?
Mm,
And I think that's going to be a big part of what raises our TRL level, is sitting down with some software engineers and working out the kind of finer mechanics of what exactly user-centric design looks like for us.
mm. I love that. I think that's going to be hugely important for you guys to succeed. So I'm really looking forward to what you guys do with that. Um, yeah. Anything else that we haven't touched on? I mean, let's just say someone's interested and they've heard what you're talking about and they would love to know if there's a spot on the team at Space Copy. Is there a place for people to apply or to reach out if they're interested?
I always say to people, reach out to me directly. I'm pretty active on social media, with whether that be LinkedIn. We have, of course, our company website, spacecopy.com is the official site. That's only us. There's a contact form there at the bottom. We're doing internship opportunities throughout summer of 2024. It's remote opportunities too, so that's good for people to get engaged no matter where you're coming from.
Yeah.
So if you're on the engineering or even just the STEM side of things and you want to be a contributing part of our mission, then we're happy to talk with you as an intern. And then if you're looking at a larger, more collaborative scale, whether you're another business or whether you're with an affiliated research institute, we're always looking to embark on R&D projects with partners.
Mm,
So definitely encourage people to reach out, come and see what we're doing, keep up to date with us. We have monthly newsletters where we share some of our amazing progress, and we're always at a different convention or event.
mm,
I myself personally am going to be taking a little trip down to Orlando, Florida at the end of
mm.
January to attend the 50th annual SpaceCom Expo.
Oh, cool.
So we're looking at, I believe it's around 5,000 people coming down for that event.
Awesome.
Additive manufacturing is going to be, I think, one of the top 6 subjects that's going to be discussed there.
Wow.
There's going to be tons of NASA people, tons of Department of Defense people. So definitely reach out to our team if you want to become involved, because we are happy to have that conversation, whether you're joining our team or you want to sign a contract to become one of our clients.
Amazing. Uh, One of the things that we talk about when we close out this episode, I like every guest to share. What is something that uh, whether you could tell yourself as a young person interested in space or science or STEAM, or some advice that you would give someone today who is either still in school and still studying or out of the industry and looking to get back in? What's some advice you would have for those folks?
Wow. Oh my gosh. So many things come to mind. I want to say, first of all, don't ever lose your passion for what you're doing. Always stay up to date with the industry news, do your research, treat it like a hobby, and it's never really work. You know what I mean?
Mm-hmm.
So, what I say to people, and I like to do some mentoring throughout my volunteer work, especially with the, high school students and those who are just entering post-secondary, is to take a step back and look at the entire space industry, all of STEM, everything that's involved in science, technology, engineering, art, and mathematics, and look at the different verticals and the different subsectors, because there's so many different disciplines.
Mm-hmm.
And it doesn't even have to be, you don't have to be an engineer to get into space. You can go down the degree of business. You can go down the degree of getting education in law and becoming an aerospace lawyer. There's
Mm.
all these
It's
different kind of
crazy.
yeah, unconventional methods for
Mm,
figuring out how you integrate into the space industry as a whole. And I think taking a step back, looking at the industry, seeing first of all where there's a gap, where we need more assistance in certain sectors,
mm,
then going back and finding what are your passions, what's interesting to you, and then looking for resources to help kind of shape that peripheral trajectory.
mm,
For example, if you're super interested in heliophysics, then you're going to go and, attend NASA workshop events that are talking about the study of the sun. Or say, for example, you're really interested on how lunar dust works. If that's your niche, okay, go for it. NASA's Lunar Surface Innovation Consortium is an organization that's created in partnership with Johns Hopkins University.
mm,
And they host monthly webinars. It's free for anybody to sign up and be a part of that consortium. And
mm,
you get to hear from industry experts, people who are still in undergraduate school, all the way to people who have served 40 years of civil service. And you get to hear about so many people's different stories, inventions that they're working on. There's community outreach and job networking opportunities that come from these kind of events. So definitely, if you're interested in space, narrow it down a little bit to find one or two things you're really passionate about, and then go out there and do your research. And if you can, attend some events online or in person if there's something happening in your area. That's a really great way to break into the industry, and you usually find your niche along that road.
Mm, I love that. Madison, you are once again adding to our theory here on people of science, and really something that I learned accidentally by starting this podcast, that the it seems that the road less traveled, or the unique path, whatever you want to call it, uh, is very fruitful. I mean, hearing your experience starting the art route, and I mean, that gave you all the experience that you really needed for space tech entrepreneurship. I mean, it's not intuitive initially that that is the way to go, but it does seem like, I mean, you're an example of it. That that is the way to go with this. So thank you for so much for sharing your story here, discussing space copy. Is there anything else you'd like to chat about before we head out?
I'd honestly like to just kind of conclude by saying you're right about the road less traveled being more fruitful. And in Space Copy's case, the road hasn't even been built yet. We're 3D printing it.
Yeah. I love that. I love that.
So I just say, as any advice to anybody who's interested in space, who's interested in science, don't ever stop pursuing your goals. And if you're interested in entrepreneurship, it's the biggest challenge that you're ever going to embark on, but it's also the most rewarding. So if you're thinking about going down that road and you have a good idea and a solid value proposition, do it. Go head first, go full force, and don't ever stop believing in your dream no matter what.
Madison Feehan, thank you so much for being a guest on People of Science. It's a pleasure having you.
Pleasure to be here, Alex. Thank you so very much.
All right, folks, spread love and spread science. Thank you for joining us for another episode of Today in Space. Be well. See you next time.